Morning, everyone. Welcome to an exciting webinar on next level generator reliability. In today's session, we're going to tell you a bit more about asset health management and how we apply technology to ensure 24/7 availability of generators. I'm Rhynard Prins. I'm the Business Development Manager for Asset Health Management. I've been with Pragma for more than 8 years, where I've had various positions. And at the moment, I'm involved in sales and developing this business unit. I'm joined by Morne Steenkamp and Wikus, and they're also going to introduce themselves.
Thanks, Rhynard. Hello, everybody. I'm Morne Steenkamp. I have the privilege of being part of the Pragma family now for about 20 years. My main field of interest is supply technology, which is coincidental the topic of today's session. So I'm really looking forward to it. Thank you.
Hi everyone, Wikus, been with Pragma for 10 years, now involved with the asset health management side, industrial engineer, and looking forward to our session. Thank you, Rhynard.
Thanks, Wikus. So I'm going to briefly take you through the agenda for today's session. So I'm going to start off with introduction by showing you a video of asset health management. Then I'm going to give you an overview of the solution architecture, explain how we communicate with the generator, also show you a couple of dashboards. Then Wikus is going to take you through some of the demo capabilities. We're going to do a short poll where we're going to ask you a couple of questions and have a discussion around that. And then also we're going to go through some lessons learned, some of our experiences in industry, and Morne Steenkamp is going to share that. And then I'm going to run you through a business case where we look at the estimated monthly cost savings and what we've seen with our current clients. And then we're going to end off the session with some questions and have a discussion around that. Then I'm going to give you an overview of the solution architecture and how we actually communicate with the generator. So at the bottom of the page, you can see there's the generator itself with the generator's controller. So we interface with the generator's controller by installing a gateway device. And through that gateway device, we communicate to the generator via 3G, 4G. We can also use Wi-Fi and a LAN cable to speak to the generator. Once we start connecting the asset, we can start monitoring all the parameters of the generator. You can see there it's intentional. We actually create a digital twin of the generator where we can monitor all the parameters like fuel level, battery voltage, load, all the information you can typically read from your generator's controller. And then we can also do business intelligence. So we can use the information that we gather and not only measure, but also record and trend the data. And we can use that very effectively in order to make intelligent decisions. We can, for example, compare similar makes and models of generators and their performance while they're running. Because we've got such a large asset base that we're looking at, we can actually compare very similar generators and look at their performance. If you look at one of our clients, for example, one of the few retailers, they've got identical generators in the same operating environment. They were installed at exactly the same time. So we can actually compare those generators with each other to look at very interesting information to see if the one is performing better than the other one, for example. Then on the mobile app capabilities, we can make our mobile apps available not only to the on-site staff at the client, but also to the contractors. And it just makes the data velocity a lot easier and quicker, and also make the processing of the information easier in terms of acknowledging and receiving notifications of any alarms and things that happens on the generator itself. And then on the maintenance management system side, that's where we've configured a very clever solution for generators specifically. So it's been well thought out. We've installed and we've configured very clever scenarios to be able to manage the generators effectively. For example, on refueling management, we've got scenarios set up for load shedding where you might want to consider refueling a bit earlier if it's going to be a higher stage of load shedding. So all of that logic has been configured in the maintenance management system. And here at the bottom, you can see a picture of the gateway device and where it's installed. So it's approximately the size of your hand, and we mount it inside the panel of where the controller is situated. And as soon as the device is installed, it's plug and play, and from there we can actually start delivering the service. Okay, so then in terms of the dashboard capabilities, so as soon as you connect these generators, what do you actually see and what can you actually do with that information? So what you can see here on the screen is a typical client. We've set this up for one of the major banks in South Africa as an example, where you can see 75 generators across South Africa. And it gives you a nice overview of the health of these assets on a high level. So it helps you to prioritize your risk and to manage your assets a lot better by having a single view of the truth. And on the right-hand side is some very useful information that you can set up as an overview. So if you want to mitigate your risk on a high level, you can look at things like, for example, the amount of generators not available, amount of generators currently running, amount of generators in manual mode, which means that it won't start automatically because it's not an auto mode. Also the amount of generators running low on fuel. So you can truly customize this according to what the priorities are for your business, and you can set up the specific KPIs to be able to manage that. So if there's certain things that's important for you, for example, on the cost transparency side, if you want to have some KPIs in place to be able to manage your cost on refueling, for example, you can also include that on this specific report. So we call this a cluster view. So as soon as you start zooming in on this view, you can see the exact GPS coordinates of the generators themselves. And as soon as you click on that specific generator, it opens up a view like this, where you can see the connected asset with all the relative information. So what you see here on the screen is the digital overlay that we've created, where you can see at the moment the power is being supplied by the grid for the business. As soon as the power failure occurs, you'll be able to see what happens with the generator while it's running. You can then see the power being generated by the generator. You can see the RPMs, you can see the fuel level, you can see if the battery is being charged, and it gives you a nice visual indication of what's going on with your generator. And what we've done here is we've really tried to customize it to make it easy to see the health of your assets. So we've broken it up into two sections. The one is to be able to see your readiness, and the other one is to be able to see your operating conditions. So if everything is green under readiness, we know the generator should be able to start. For example, your communication should be online, the generator should be in auto mode, the emergency stop button shouldn't be pressed in, and the generator's battery should be charged, and you should have enough fuel. So if all of that is green, the generator should be able to start. And then while the generator is running, we'll also monitor a lot of other things to be able to ensure that the generator is running optimally. Okay, and then I'm going to hand over to Wikus to give you some more information on the other demo material we've got available.
Thank you, Rhynard. Yes, so if you look at the notifications that's available through the system, there's a little process diagram here, and then you have different platforms where you can get your notifications, either be it on Telegram, as you can see on the right-hand side, or via email or apps or whatever the case may be, whatever you prefer. Basically, if you look through this process diagram, the notification comes in, goes to you via different channels, and then also the acknowledgement of that notification, very important. It doesn't help you get a notification and there's no acknowledgement of the notification going through. And then also the escalation. If there's no acknowledgement of the notification, then the escalation to different levels for some peace of mind that the alarm or the notification is being actioned. And this process, there's different processes in place for all the notifications and all the alarms that's happening in your system. So if we just look at the monthly report, so in addition to your notifications and your weekly and your 24-hour monitoring, you also get the monthly report. It is in this format. Basically, this is for a generator, and you can basically see the overview and statistics of your generator or generators, and then also asset health. Where do we see your asset health being? In this case, it's excellent, and you can go through all the statistics of your generator on this page. And then also your statistics on the maintenance work, some trends, also the fuel levels and the fuel usage, and then monthly event-specific statistics. All of those things are available on your monthly report. Contractor performance on the management side. There's another process diagram for your contractor performance, and then also the trendings, the trends for your running hours and all the other statistics that you need. Fuel consumption, alternator voltage, all those things are available on your monthly report. Let's have a little poll. So there's 3 questions. Will only take you a minute or 2. Please answer those questions on your screen now. Okay, so let's have a quick discussion on the votes. I think the first question, there's no surprise there. Generators in South Africa, very, very important. I think we all feel it at the moment as well with the load shedding going on. So 71% of the participants said generators are critical to their business. And then also 29% says it is critical, but they have enough redundancy backup power that it's not as big of a problem. So no surprises there. And there's not one person that says they have their backup power under complete control. Okay, so then the second question, reliability issues. Is there reliability issues with your generators? 29% of you said, yes, you have reliability issues. So the combination between the first question, a critical asset that has reliability issues, that's obviously a big problem. And then 43 of you said you have really you have problems with your generators, which is a good thing. And then also 29% says, I have no problems with my generator. So it's a even distribution on that side. About 70% of you said you have problems with your generator from time to time. Okay, the last question. Do you have reporting analytics available for your generators? So 29% said yes, you do have reporting analytics available. And then some of you said 14% says you have some reporting available, and then the majority 57% you have no reporting analytics available for your generators. So I think the 3 questions begs the answer. So what are you doing with how are you managing your critical asset? And if you have no information available, obviously that's something that you have to look at. So interesting results. Thank you for the votes. And thank you.
Thanks for the opportunity. And what we want to do is just to share some learnings that we've picked up over the past months or years that we've worked on generators. Just some knowledge sharing to see what we've picked up, so that hopefully somebody in the audience can find it useful and maybe it can save you some headaches in the future. So it's just a couple of the specifics. So the first one is, if we talk about fuel sensors, and that's probably, if somebody asked me what is the one thing that you would make mention of a lesson, then it is probably the first one that always comes to mind. And if you ask the question is, can you trust your instruments? That's actually what we're asking for, because on the controller, obviously that is your instruments, and you can get some of your values from there, and from there you make management decisions, or decisions when to refuel or how to manage certain things. And the short answer is, initially, no, you can normally not trust the instruments when it comes to your fuel level for a generator. I haven't encountered one instance where I came to a generator and we had actually accurate information. And there's various reasons for that. The first probably reason is, as soon as your generator gets installed, you get certain fuel sensors that get installed with that generator, which does not understand the scenario or the configuration of that generator that has been installed. And the default settings on the controller is quite often overlooked and not being set up for your specific installation. And that is normally the reason why it's not done. So as soon as you've pick that up and you resolve that issue and calibrated your sensor properly, then definitely you can trust your instruments. What I'm saying is initially when we get to generators, I haven't experienced one where the fuel sensors, for instance, has been calibrated correctly. So what is the first thing that is normally the problem? So the tank size versus the capacity displayed. So most of these controllers, for instance, this deep sea controller, as far as I know, the default setting is normally for 1,000 liters. So as soon as you install it, if you don't set it up and make your own measurements and determine what is the fuel capacity of your specific tank that you've installed, then it will show you probably 1,000 liters. And we've seen that a lot. So what happens then is if you look at the display, it will tell you, for instance, on this one, it's got almost 800 liters in. And if it falls below that, it will give you the indication of how much is left. And quite often people want to use that information when you have refueling done, for instance, to verify your amount of fuel that's been put in compared to the invoice that you get. And quite often you can't use this information. So it actually puts you in an awkward position. You just have to approve whatever the guy charges you when it comes to refueling. So the first one is the tank capacity versus the displayed one. The second one is the meter calibration. And I'll come back to this one in the next slide. I will talk about that a little bit more. But the meter calibration is really, really important. And there's two ways that you can normally do it. We can do it up front or over time, but I'll get back to that as well. And then the last one is the tank configuration versus the sensor resolution. So you'll see on these fuel sensors, there's normally when you look at the data sheet, they will actually stipulate what is the resolution or the accuracy on it. This one, for instance, is a very common one that we find in the field, and it's got a 10 millimeter resolution. And the reason why it's a problem, and you would rather go at least for a 5 millimeter resolution, is these tanks is normally big flat tanks, and the generator is placed on top of it, which means 10 millimeters in such a big area can actually equate to close to 50 liters. So your accuracy at best is normally close to 50 liters. So that is normally the biggest issue. So if we go to the next slide, that is a typical configuration on the left-hand side of a tank. And what we often see is those fuel sensors comes within specific lengths, and it doesn't necessarily cater for your fuel tank. So quite often you take the one that is as long as possible, but quite often we've seen a lot of those which is relatively short compared to the depth of the tank. So for instance, that one, that is a representation of one of the real installations that we've got. If that fuel sensor comes to its bottom, where it shows 0, there's actually still 40% fuel in that tank, for instance. So you need to calibrate it. What is 100% and what does it mean when that sensor reaches its limit at the bottom? Is it really 0 or is it actually 40%? And what we've done for this one, for instance, on the right, you'll see the configuration on the controller. It allows you to stipulate certain points, and with that you can recalibrate that sensor that you actually get true information in. So for instance, you'll see those blue dots. Those blue dots are specific measuring points that we've got. We knew, for instance, when it is 100%, we know when it's 60, 40%, and so forth. And you'll see it actually hit the bottom at 40%. So which actually helps it to be very accurate. The problem with that is as soon as it reaches 40%, you don't know what's happening from there to 0 because that sensor can only show you up to 40% and nothing below that. So for that, you must understand what you're seeing, and then you can start trusting your instruments and make proper use of it. Okay, so that's from a fueling point of view. So let's carry on. What we've also done is in combination with that exercise of calibration, we've looked at a lot of the generators that we monitor, and we say, let's plot the typical size of the generators compared to its fuel consumption, the liters per hour fuel consumption, and see what we get from that. And it actually ended up that we can actually draw more or less a straight line through it, which is quite interesting. And then obviously we can derive an equation. You can see the equation there. And we can utilize that equation to more or less determine what will be a very good guesstimate of your fuel consumption for any generator. You'll see here at the bottom in the smaller ones, you get a little bit of a deviation, but it's relatively small. So this is actually a good correlation of fuel consumption compared to the size of the generator. And it's not always just the size. Obviously, you must also take into consideration what is the load that you put onto that generator. So this is earmarked at about 80% low. If you use lower load, obviously you must use that load figure and not the generator size. Just for interest sake, it's quite a linear graph that we ended up with. Okay, next one. Rhynard mentioned that we can do proper comparisons or benchmarking of generators that's in the same area, especially in the same load sharing or load shedding zones, which is actually quite interesting. And here, for instance, and you can ignore that one of the 7th of February, that is just a bit of an exception. There's a different reason for that one, which I'm not going to go into right now. But for the rest, you can see there's two generators more or less next to each other in the same load shedding zone. And the question came in, but why does the one start so many times more than the other one? We expect there's a certain amount of load shedding that happens and a certain amount of testing, which also corresponded, for instance, with this client. But the one started a lot more. You can see on the 5th of January, the one started 12 times compared to one on the 2nd of February, 3 times. And then it was more or less on par. As I said, ignore the 7th of February. And then the 12th and 25th of March, we had a very similar situation. And what we had there is that there's what is it called? A fuel line issue, and it was a normalized problem. The guys on that site were so used to having to start that generator more than once to get it going before load shedding that they never reported it. But if you compare the two, then at least you can see there's issues with the one they have to restart, or there's start attempts of the controller that is different to the one that you would have expected, and we can compare it with one next to it. Just a nice way to pick it up. So having the information plotted over time enables you to be able to benchmark and trend certain of the information. The next slide is very similar. So it's a different client. And it was something that we recently picked up, very similar, also two sites very, very close to each other. And we recently picked up from middle or end to April. The one started once again starting more than the other one, and nobody picked it up on site that it wasn't, they wasn't aware of it. Because the generator will have up to, let's say, 5 times, depending on the configuration. It will try and start up more than once to get it going. And quite often it happens in times when people is not there, so nobody notices it, except for the amount of starts that you lock from the generator, and you can start picking it up. So this one is busy with investigation just to see. But if you leave this lie, you will have serious reliability issues in the near future. So it's just a nice way to proactively pick up certain issues that is getting there. Okay, next one. Talking about over and under spec of generators. Now, this can be a topic on its own to some extent, but the rule of thumb is you want to spec your generator correctly. If it runs, you're not supposed to let it run on the less than 30% of its capacity. And you don't want to plan for more than 70% just to make sure that if something out of the ordinary happens, that it can still cater for it. So the sweet spot is anything between 30 and 70% of a generator. Running it on a lower load than that is really bad for the generator, and you're reducing your asset life dramatically. And there's a whole discussion around that. I'll touch on it on the next slide, but we'll get to that one. So we just look for this specific client that's got 6 generators. What is the sizes of it? And over a couple of months, we trended for each load shedding and event that it ran. What was the average power that it actually used, and what was the maximum that was used? And once again, because we've got all the data in the system, it's quite easy to extract that. Excuse me. So you can see on average, the first one running on 33% of its capacity, the maximum it drew over that period of time was about 56. And so you can compare all the ones. So if let's put some focus on number 3, for instance, running on average of 24%, which is below the 30, which is really bad for that generator. It will reduce the asset or expected life dramatically. And at most running at 40%. So there's a few things that we can see from here. We can recommend a replacement asset when we get to that point in time. So when we replace that asset, most of the time, clients replace it like for like. So if they had a 240 in there, they will put in a 240 again if they don't have the information and had a look at it. So here, for instance, we will recommend a smaller generator, which will reduce your capital layout, but it also reduces your fuel consumption. It reduces your maintenance cost on it. So it really snowballs a lot to have the right generator selected for your application. So the other alternative is sometimes they do have more assets or devices that they can actually link up to the generator. We often use this information as well to see what is the capacity and what we can safely add to the generator if the power goes out. So just nice information. Slide after this talk about if you don't run a diesel generator to its capacity. So that saying there that says diesel generators are designed to work hard and they need to work hard, that is very, very true, because you get typical glazing and carbon buildup if you don't have it. Now, that is a topic that I said is actually quite interesting when you unpack it a bit. What is the reasons and why it happens and what is the result of that? But as I said, it absolutely reduces your expected asset life dramatically. And we've got some good articles about that. So if anybody's interested in that, you can always contact us afterwards and I can share some of that information. But it's a huge problem. So I don't think you're actually sparing a generator if you're not putting proper load on it. It is there to work hard. So the key switch one, specifically for the reason of this glazing and making sure that we run it under load, we often see in bad practices out there that clients start their generators with very good intent once a week with no load, and they run it to make sure that it runs fine, and then they think they're actually increasing the reliability. But remember, if you start it without load, it means you're running it without load, which results exactly in what we said about this carbon buildup, which is bad for the generator. So it's actually better to run it less frequent, let's say once a month, but under load. And quite often the procedure to do that is not there. And secondly, people don't like for the switch gear and the isolators to switch that. It's quite terrifying, especially for me, I must admit. I'm a mechanical engineer, not electrical, so electricity scares me quite a bit. So for that reason, we implement a key switch where we simulate a power failure, and then we test the whole system. So as soon as you simulate the power failure by switching that key switch, it shows a phase dropping, and the switchgear will pick that up and transfer the load from mains to the generator. The generator obviously would have started up by then and take full load as if there were a power outage. And that's actually a very easy way to do proper load testing on a generator. So it's actually quite nice. You can we actually do pick it up from time to time, and some clients also have it installed without other monitoring systems. So it's in general a very, very good practice that I can recommend. Okay, and then next slide. So the service intervals, one client also came up and said, but we don't have monitoring system in place. We're not sure how much the generator is running over time. So we rather, instead of working on a 250 hours versus a 1 year service interval, because we don't know how many hours it actually ran, let's rather service it once every 6 months. So trying to be very conservative, and we just said, let's from two ways do the calculations. One is, let's look at the actual figures, and let's also just estimate. So if you look at that first table, it will say, if you test it, and that scenario, the client tested it every week for half an hour, that bad practice that I talked about. If we do that once a week for 52 weeks, it will equate to 26 hours for a year. If we do proper load testing once a month for an hour, it's equates to another 12 hours. And then if we service it, and part of the service, they normally run it for about 2 hours. And let's say, I know there's a lot of load shedding at certain points, but there's also points that there's no load shedding, but let's average it out and say there's one load shedding event every week of the year. And if we add all of that together, it comes to about half of the 250. I think it's about 144 hours in a year, so which is far from the 250. So even being relatively conservative, you'll rarely find it that generators run more than 250 hours in a year. So then if you go to the graph, then we also looked at what is the normal distribution of the cost of servicing a generator. And obviously the smaller generators, as I said earlier on, is a little bit cheaper. The average one was about 9,200 Rand, and that was data that we've accumulated for this client from about January 2019, I think, to close to the end of 2020. And one round of servicing those generators cost about 2.1 million Rand for one service of each of their generators. So if we introduce a second service for their generators in that year, if it was not necessary, they would have wasted another just over 2 million Rand. So just by having the information and doing a little bit of calculations, you can make better decisions and be careful not to be over conservative and spend a lot of money.
the question often comes up, what's the business case for a solution? And how can we motivate this to be able to add this as a value add for our business? And it's actually a necessity for a business if you're looking at critical assets. So what we've done here is you can see it's a relatively small generator, 80 kVA generator that you would typically find in an office type environment, where we say the estimated replacement value of that asset would be around 230,000 Rand. So some of the cost saving elements that we have seen with clients and that we can calculate is, for instance, to increase the asset life. If you're looking at the life cycle management and some of the decisions that Morne also touched on, if we say we're going to increase the asset life with at least 5 years, if you're looking at that replacement value, that's more or less the amount you're looking at. Then in terms of the reduction in maintenance costs due to early failure detection, so what we say there is we're going to reduce the repair of a large failure once every 5 years. And we've calculated the average cost of what it should be for that failure. And if you work that out, that's more or less the monthly cost saving amount you're looking at. Then we also briefly touched on contractors. So in terms of our management service, what we also do is we do cost benchmarking. Because we've got a large contractor base, we've got a large amount of assets, we more or less know what it should cost for certain types of work to happen on a generator, if you look at maintenance or repairs or any type of work required. And we can often look at that cost and do a cost comparison to see if it's relevant or not. So in terms of that, we see about a 15% cost saving on average. And then refueling on its own it's almost a science that you have to work out, and it's often something that's not done correctly in industry, and people tend to just refuel the generator every time that it actually ran. So what we say there is, in terms of that planning, what we say we're going to do is prevent two early refuelings per year. In other words, if you refuel too much, we say we're going to prevent at least 2 cases of that happening. We have got one client that we spoke to, for example, where they've got a person sitting next to the generator and topping the generator up constantly. And if you look at the size of the tank, it's not feasible to do that. So that's on that point. And then the other one is to be able to prevent 2 instances of after-hour refuelings, simply because if you need to refuel after hours or over weekends, the fuel tends to be more expensive, and in that instance, everyone's running around after fuel, and it's really a struggle to be able to manage that refueling function effectively. So that's the cost-saving elements on refueling. And then there's also an element of your own staff overtime that needs to go out to the generator, and then also the reduction in maintenance management resources, which we conservatively estimated at around 8 hours for you to be able to send some maintenance resources out to look at the generator. Then the big cost saving element that we see is the opportunity cost. So if you look at the prevention of 1 failure every 5 years with the potential damage of 500,000 Rand, which is still very conservative in a lot of businesses, that's the cost saving for that would be more or less 8,000 Rand. You can actually increase that amount dependent on your own business and your business case. And in a lot of cases, it's even more than that. So that's the cost saving element on that one. And then the last one is the load testing that's being facilitated by on-site staff. So as Morne mentioned, we recommend also installing a key switch, which often enables the facilities management individual on site to actually conduct a load test without getting a contractor out. So there's a cost saving element on that as well. So yeah, so it just gives you an idea of the estimated monthly savings that you're looking at for that size generator. As you start looking at larger generators, the cost saving amount also increases. All right, so that's everything on the costing. And then I just wanted to mention that Pragma is truly a global business, and we've designed this service specifically to be available anywhere in the world, and we can deliver this service remotely. And this just gives you an idea of Pragma's footprint at the moment. Thank you so much for attending the webinar. I'm going to give some time for questions. We're going to look at the Q&A. You're welcome to scan the QR codes on the screen if you want to add us on your phone. you're welcome to send us a message and we will come back to you. Morne, do we have any questions in the chat or on the Q&A?
Yes, there's just a few questions. So the first one that I've seen, the question is, how can we control overall operations effectiveness of generators? So if we talk about overall operations effectiveness, referring to the availability most of the time, so how can we control that? So I think that the first thing is to be able to control it. You need to measure it. The old saying to measure is to know. So let me just say, there you go. So to measure is to know. So the first thing that you need to do is you need to measure it. As soon as you measure it, you can see what is the availability or the overall effectiveness, and then you can start controlling it. And the way that we control it for generators is mainly looking, as Rhynard said previously, is remember that dashboard that we had to look at all the stuff that is necessary for that generator to start up. Is it in, and the stuff that we normally find for generators not to work. So in principle, the mechanical equipment, and if you look after them, they're relatively reliable. So if you maintain them well, then they will be reliable. But there's other factors that quite often come into play. For instance, we get battery theft quite often. So as soon as somebody has checked it, let's say quite often some of our clients, they said that once a week, the maintenance guys will go and check on the generator. So that's cool. But as soon as he walks out there and 10 minutes later, somebody comes and steals the battery, you're back to square one. So to be able to pick up those things, if somebody refueled it and they forgot to place it back into auto mode or depress the emergency stop, for instance, then generator will not start up. And that's just all the typical things that will cause reliability issues or availability issues. And that is the stuff that we really focus on to make sure that those small things which normally catch us out is in place. So that for that reason, all of those things get monitored. As Wikus also mentioned, there's processes set up. So as soon as, for instance, if a battery gets disconnected, the maintenance manager will get notified of the situation. If they don't respond and acknowledge that they received that message, somebody else will get that message will get escalated to a line manager typically. And if that person didn't acknowledge that they get the message, it will be escalated to us, and then we'll start running around, especially if there's load shedding on its way. So our full purpose is, and that's one of the reasons when you look at the cost savings calculator, one of the biggest components is that one event that the generator did not start up, because that normally causes the most problems or the biggest cost element when you look at the cost savings. So if you can prevent, even if it's once in 3 to 5 years, if you can prevent that one instance of where the generator did not start up, but one day when the guys stole the battery on a Friday afternoon, or it was the controller was not in auto mode, whatever the case might be, if you can save on those instances, then you're really in control or improving the overall operations effectiveness of the asset. I'm not sure if I've answered that good enough. I hope so. So that is the way that we do it. Let me just see if there's other questions. There's another small statement probably. So guys say we've installed a monitoring device on our generator, but we still got caught out. So it's exactly what we just talked about. So the way that you do it, and I think it's one thing, and if we look at asset health as a service, it's one thing to measure certain things. It's something else to make it work for you and to make something happen with it. So it's important to get that notification, but nobody is on 24/7 standby. Everybody goes to a braai or goes for a swim or a jog or whatever, and you get that notification and you don't react on it. So the important thing is this whole process behind it to make sure that if somebody do not get that message, it gets escalated and escalated so that you end up in a situation where somebody do react on it, and make sure that we do not influence the availability of that asset. Yeah, that is the one thing. The other thing that maybe comes to mind when we also talk about, if you trend this information, quite often this person said they've got a monitoring device. We've seen a lot of it. The information comes through and you get notifications, but you quite often do not get trending of the information. You can't see what was the capacity that it was running on, how many times did it actually try to start before it actually started up. And we can start trending that information, even if it's not live, it's once a month or whatever the case might be, you start trending it, you pick up certain other things that actually can help you a lot to increase the availability of those assets. you pick up those things up front, and let's say there's a small leak on the fuel line, you can start picking it up. You can solve that problem long before it gives you any availability issues. Okay, let's go see last one Q&A. There's another one. Okay, so that was just a thank you note. Other question is, where can we get benchmarking data to compare our data with? It's a good question. We often search for information. I search it myself because I love benchmarking, but there's actually very few data out there that is useful to measure my data on quite often. So I think we're in a fortunate position because we've got a lot of information. We monitor a lot of generators, so we can compare. You'll probably have a lot of 400 kVA generators where we can compare it, and probably in the same load shedding zone, for instance. So we've got our own information that we use for benchmarking to look for information out there. There's quite often information, but not in the way that we normally benchmark it. For that, you need very similar and a lot of information to be able to benchmark. For instance, what is the fuel consumption, as we talked about? How many starts do we compare? How many hours does a generator run for every start? For instance, what is those averages? You can actually pick up a lot of things there. Unfortunately, I can't point in a direction where to get a lot of benchmark information. Maybe you can contact us if you if you want. No problem.
You can point them in our direction.
Pardon?
No, I was going to say you can point them in our direction, Morne.
Yeah, you're welcome. We like to share, so welcome to come and ask for information, advice. The best things in life is free, so we can we can assist there as well. That's the only questions that I see, Rhynard. Nothing else. Maybe if somebody, any last questions, maybe to come in. I'm not showing anything, or maybe you guys see questions that I don't see, perhaps. So I'm just scrolling.
Morne, I just want to double check. Did you answer the question, can the key switch be automated to perform the load test remotely? If so, what would the cost implications be?
Sorry, I didn't see that one. Thanks for that one. So in theory, yes, you can do it. We haven't done it, to be honest, because we combine the load testing with a couple of checks. So once a month, we schedule a load testing and we set out half an hour for that. And we want the people to be there to do certain checks while the generator is running. So sorry, I'm telling you the reason why we don't do it, but I will come back to your direct question. So there's quite a few other things we will look at. For instance, if there's any leaks, if there's quite a few checks that you can do while the generator is running, and we prefer somebody to be there. We do not like it except if we've got a visual on it to start any machine like a generator remotely. It's sometimes a bit of a risk, but in theory, that the key switch, I can actually install that one and do it remotely very, very easily. It's literally just a dry relay that you implement there. So that key switch is actually just a manual dry relay. You can very easily install an electronic dry relay, which we can remotely activate very easily. So the answer is very, very easily doable. We don't do it, but it's definitely easily doable.
And in terms of cost, it's not usually that expensive, Morne.
No, it depends on what you use for it. You get devices for a couple of $100 which you can actually link to your cell phone, which has got a dry relay. It's literally a couple of, you're probably under $500 you're able to do it. It's not difficult. The question is just be sure if you want to do it, firstly, and secondly, if you do it, just get feedback loops as well. I wouldn't do it if I don't have visuals on it. If I, for instance, got my dashboard and I can start it up, and I know it's in the middle of the night, there's nobody close by, for instance, and I can see it starts up, and when I switch it down, I can see it actually switches off, and I can monitor it. So being in control of it, I think that is good. To do it blindly, I would be very hesitant. We've had a few examples of clients, for instance, where in the past, they start up the generator and for some reason it doesn't switch off after load shedding. And then what happens is obviously it runs without load for the rest of the time, and it runs till the tank is empty. And tomorrow when there's actually load shedding again, it doesn't start up, there's no fuel left. We've had about twice that I can think of now where that happened. So the suggestion is just if you do it, as I said, it's easy, but make sure that you've got the eyes on it, that you make sure that whatever on site happens is exactly what you would like to happen, then it's maybe not a bad idea.